chat now. All right. Okay. Okay. This should be good. Well, you shoot this. No one's coming. So I'm gonna close my door real quick. Okay, I'm back. Okay, so this is like the third time I'm doing this. Like this is my first ever living, like overall. But essentially, this is supposed to be office hours, and if you have any questions and all, feel free to ask. But I'm also gonna do like a crash course of 71 for the next like 15 to 30. That's just all right. Oh God, this is sorry, dude. I don't know what's happening. But yeah, I'm also just gonna go over like fundamentals of MATLAB. So I have to share my entire screen for this, but we should be able to do stuff. Now, if there is a way, just to make sure nobody interrupts, because I do not want to get. Hmm. Interesting. All right, let's hop over to MATLAB. Now, hopefully, my do not disturb doesn't work. If it does, I'm gonna have to take this down. Um, because I just don't want to get any notifications while I do this. But yeah, okay. So essentially, just a quick review, quick sesh about MATLAB. Um, it's just like any other coding language, except this is more in plotting and simulation. So you can notice I already have a bit of code here. Um, and this is kind of telling you the different topics prior to exam one. So you can see that the main stuff that we're going to be testing you on is variables, functions, vectors, and masking. It's just those four topics, and within those four topics, you have different functions that you have to know, certain rules that you're going to have to follow. And so for variables, we know that essentially they store data. So think of it as like you have a box which data can be stored in, and then you have a pointer that points to that box. Now you can name this pointer whatever you want. That is the variable, and it points to this box that contains the data. To change that data, you may need to sometimes create another box, and you just point the variable there. In this class, though, we can easily just rewrite whatever's in the box and just point it here. That's just two ways of working with variables. You can either rewrite it, whatever's in the box, or you just make a new one. This class does not deal with objects and object-oriented programming, so most likely you will rewrite whatever's in the box. Okay, but as for now, we have three data types that we're learning, which is doubles, logicals, and characters. We will be adding more, and it's not the worst. The ones that we'll be adding tend to just store these types of data, but these are like, I don't want to say like primitive. These are like the fundamental data types that we'll be working with. So doubles contain your integers and your floating values and negative values, essentially all numbers. Logicals are true and falses, and you'll see them sometimes in the command window as 1 and 0. So if I were to do true, you get logical 1, which this is true, and then false. This is 0. Now, a logical 1 is different from a numerical 1. And the key thing is because the logical is the data type that is casted. And one thing I'm also going to mention is casting. So casting is essentially what we're doing here with these two functions, and it's literally converting from one data type to another. Now, the way that it's cast, or the way that it's oriented and shown, that depends on the function itself. But the fundamental functions, which are literally double, char, and logical, they literally are the same exact name as the data type. Just change the value to its corresponding data type value in that other data type. So like if I had, and we could practice with this, which this is a good tip that I recommend whenever you're practicing for this, is genuinely look into whatever you're doing, whatever concept that you're weak on, and just practice in the IDE. And that will essentially help you understand how functions, how this code works in an environment that you can run and test things in. So that way you don't have to do that on the exam. So if I have log1 is equal to true, let's see what happens if I just cast it to a char. It's not possible. So this is not possible. What if I did double? Works. So actually, what I'm going to do is I'm going to write them here. So we have log1 is equal to true, log2 is equal to false, and essentially char conversion see what happens. Yep. So this didn't work. And this didn't work. Interesting. Is that what an arrow does? Huh. Okay, so these two don't work. Double conversion. Let's also say I have double 1 is equal to 10, double 2 is equal to, let's just say negative 10, because we also want to check negatives and see what happens if we do that. So if I convert Let's see what happens. And essentially what I'm doing here is I'm literally writing test cases. And these test cases are just what are showing. Essentially, I'm looking and seeing what is happening, and I'm testing different types of examples. Like here, I'm just learning how the char function works. And so I encourage, it might be a little bit too late for those of you that are in the online section taking it today, but in the future, if you are studying for an exam, literally just writing code like this, it helps so much. I think my thing is laggy due to just stream, so I apologize for that. Okay. And so what I'm doing here as well is I'm just making a bunch of clear options, and you can see I have a lot of variables over here that they pertain to a different homework assignment that I use that I use MATLAB for. Um, there you go. They're gone. Okay, so we can see that these conversions they gave some sort of character, but they're not really that useful, I'd say. And this kind of corresponds to the ASCII table. The main reason why we use typecasting is because if we want to convert a character to its corresponding ASCII value. So one thing about that is lowercase a is 97, lowercase c is 122, capital A is 65, and etc. And so this type of conversion is what the char and double characters will be doing it because you can go back and forth. I didn't type anything. But yeah. And as you can see, like we have two different characters. This looks like a white space character, but to be honest, I didn't even know if that was gonna work. Yeah, okay. So this is all the character conversions I think we can think of. And I could add more, but I think that's enough for me to kind of understand what's going on. I'm going to do char1 is equal to A, char2 is equal to capital A. All right, let's do double conversions. So convert 5 is equal to double log 1. Convert 6 is equal to double log 2. See what happens. Okay, so these essentially convert them to the corresponding actual values. So these are, like we said, logical 1, logical 2. That just converts them to 1. Sorry, logical 1, logical 0. This converts them to logical 1. Though it can, sorry, I'm stammering. It converts the logical 1 to 1 and logical 0 to 0, as you can see here. Convert 7 is equal to double char1. Convert 8 is equal to double char2. All right, let's see what happens. So yeah, like I said, this is the 97, this is the 65 typecasting. So all of these work. All of these give an output. And this is what you'll typically, like, you typically use char and double more than you use logical per se. Like if I were to do convert for prime this is going to give me A. So these two you'll typically use the most. And logical conversion. Sorry, my computer's really slow, so I do apologize. You see the stream. Ooh, interesting. Okay, so interesting. Even though the doubles are not 1, they're also not 0. So it converted to logical 1. That's weird. So literally anything. Let me see if I had 0 is equal to 0. What will happen? Literally makes logical 0. So anything except 0 will give you 1. But if you have 0, it will give you 0. Yeah. And you can see that here. Okay. So this is like the basis of test casing. And this is honestly the best way to learn. And so I encourage you guys to do this, if not for this exam, the next one, because this will immensely help you understand. Like now you understand char, double, and logical, those functions. What do they do? How do they work? What does work? What doesn't work? What gives an error? What doesn't give an error? This is test casing. So likewise, you can do the same thing for sternum and stir. So the best practice I do for this is I literally just use the number 5. So 5 is equal to so then I'll do num convert is equal to stir to num of 5. And then num also, this is a live script, so I can see my outputs here when I run it versus in the command window. I recommend using an MLX when you're test casing, because with the .m file, you're just running into the command window, and you have to continuously do that versus you can see stuff here. This also is really useful if you need to plot anything. So you can just run a plot function and you'll see it on this side versus having to see it in a figure. And we'll get into that once we get into week 9 or so. Maybe even 10. Is equal to num to stir 5 dose. So literally what is happening with these lines of code is you have a 5 with quotes and you either take them off or you put them on. That is all sternum is doing. Now, you could code sternum, and the way you could do this is, well, let's ask, what is the character 5's ASCII value? 53. So if I wanted to get 5 out of this, I just have to subtract by 48. So I could do sternum hard code is literally double of 5. And I'm going to actually do this as a function. So at character double character minus 48. And what this is right here is this is called a one-line function. So you'll see that like in all of our homeworks, we've been showing you guys how to write an actual function that does a lot of steps. Now, this essentially just does the same thing, except you can just do everything in one line. This is really useful if you are coding a lot of stuff and you just need to plug in something to a formula. And I kind of demonstrate this with my homework here, which I will show for now. Here it is. So this guy right here, I use two formulas, and it's literally just the same formula over and over again. I don't have to add any other steps. I just call the function with the specified parameter, and I'll show that in a second. And it's just a simple calculation thing that you can do. We won't test you this in this class, but it's a good tip to have in the future. And then as for like an actual function, so for this transformation matrix, I had a bunch of variables. I needed to code a lot of stuff. It would have been really hard to do this in one line. So I decided to make an actual function out of this and return the matrix like so. And that way I could actually do my code as well as have a built-in function. So they each have their different use case, and it's really up to what you're trying to do to figure out when you want to use this or not. Okay. You're like the only one here. Okay. And so, like I said, for this, I could essentially do like new num convert is equal to stir to num hard code, and I could type in the character 5. Oh shit, my bad. It has a lowercase. Okay, let's try this again. Yeah, you can see what the function does here. Yeah, it does the same thing. Now you could do the same thing with num to stir, and you could literally hard code that using double. And this is this is using a function that we already know and just doing that again. But understanding how a different function works allows you to not have to code all of this. You don't have to make a separate function that just casts this, subtracts this, and then goes back to, whatever. Also, the problem with this is if I were to use A, this actually works. I get 17, and that should not be right. So I can demonstrate this here. Yeah, it's empty brackets because there is no corresponding number that goes with A using stir to num. In typecasting with char and double in the ASCII table there is, but stir to num only works with numbers. It just puts quotes on and takes them off. Okay, any questions? No, just one viewer. Okay. All right. And so yeah, even then, this hard code doesn't even work. You might even have to make a function that just asks, is this so yeah, you probably might need to make an actual function for this. I just decided to use this as like a quick example. But you could program stir to num using just double. It's not worth your time. That should be all that I think variables and data types are, and functions. Oh, functions, right. So you can see in this one-line function, I have this character, typically you only get one output out of one line functions versus with normal functions you can get multiple. I'm not entirely sure. There could be a way. I haven't experimented with this, and if you're curious, I encourage you to go do it yourself. Um, but in normal functions, which we do test you on, you have inputs and outputs. Now, with functions, you don't even have to have any of these. You could have something that says function test, and this works. Well, let's do helper. Yeah, this works perfectly fine. But we do sometimes want to actually have outputs. So we make an equal sign, we can make an output. And likewise, you don't need to have any inputs. And likewise, I can also delete this. You don't need to have any outputs. The key thing here, though, is if you have multiple outputs, you need to put them in square brackets. And the reasoning why is because a function takes in a variable, think of it like an index, and then your output has to be stored in multiple values. The only way we've learned so far, in fact, it's the only way that functions actually do it, to my knowledge, is you essentially concatenate them within a vector. Yeah. And so without this concatenation, and this is a good thing to test as well. If you try outputting something with multiple values, you will only get the first value. Let me see if I can try doing this. Also, you can't have a function at the beginning of a file, or at in between lines of code. You have to have it at the end. That kind of goes into more vectors, so I'll go into that after I talk about logical operations. Yeah. Yeah. And the inputs are just comments. If you could write a function header correctly, then that you will guaranteed get at least a point or so. Like, you will not walk away with a 0. You can at least write the function with the right inputs and outputs. That's at least one step of the problem. Okay, so this kind of goes into masking. But to understand masking, you have to understand the vectors first. Are we doing 12, 15? Okay, not bad. So let's go to vectors first. So, like I've shown you, we can have variables that just contain one piece of data, but in reality, we need to look at multiple values of data. Like, think of like a spreadsheet, for example. You don't want to just look at one piece of data and call a variable for every single one. That takes up too much space and memory, and it's incredibly inefficient to traverse. So the alternative is you create containers that can contain multiple values of data. And the way we do this is with vectors. We call them vectors because they usually have one direction, essentially a vector is a one-dimensional array. And we'll get into arrays after exam 1, but with vectors, let's go here. It's like Despicable Me. They contain both a direction, which is usually left to right, and then each of the values inside the vector have a magnitude. So, like I have here, I have a vector of 1 through 5. There are multiple ways of creating a vector. So, here, let's do this. Vec1, 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 Vec2. So these are two ways of creating the same exact vector. Now you could spend time typing this, or you could just use the colon operator. Choose which one would be faster. You can index one element, you can index multiple elements. So for this case, I'm indexing with the colon operator. I could do 3, 1. Let's just see if this works. Okay, let's use, because I want to make sure that this is actually giving the values and not anything different. I'm going to label this 6 through 10. This should give 8 and 6. Yep. Okay. Interesting. I have no idea what that is. Okay. Are we doing batteries? Okay. Steadily climbing. So with vectors, we also sometimes want to extract out of it. This is called indexing. Now, this vector right here is 6 through 10, correct? But this vector right here, which is obviously a different vector, I'm using this as a visualization, is literally the indices in which each of these values are contained. Think of like a cell block, and then think of like different values stored in each of these cell blocks, and they have a label for them. So let's say these numbers are prisoners. So 6 is a prisoner in cell block 1. 7 is a prisoner in cell block 2, and so on and so forth. These indices are very important, especially when we want to extract them. If we want to call prisoner number 8, we need to know where exactly 8 is. Hence why indexing is important. And so we use indexing to extract that. And you can see here, to get the first element, we call the vector. So that's like walking up to that cell block. And then you say, all right, calling prisoner in cell block 1. And so you can see we use parentheses. This is similar to functions, very similar, because we have parentheses, and then we have the specific input of who we want. I say that because functions and vectors are kind of similar in that sense, especially when you want to get multiple values. Right now you can see I have one output, but I could probably use more. And we'll explore functions that actually do that, especially when you want indices. So I can also index multiple values. And I indexed, so this is going up to the cell block, asking for, okay, prisoner at cell block number 3 and number 1 in that order. And you get 8 and 6. Now the colon operator is also useful because let's say I wanted to have a list of prisoners. Let's say there are 10 prisoners. And let's say that every other value is empty because there's no prisoners in there. Let's say that the guards decided to be lazy. The first one is vacant. The second one is not. The third one's vacant. The fourth one is not. That's what I mean by every other. So then you could essentially call the prisoners as cell. So these are the prisoners that actually exist. 2, 4, 6, 8, 10. This colon operator allows us to essentially essentially traverse through a vector while also choosing how we go, like what step we go. If you do not specify a step, ooh, what happened? My phone's bugging. Interesting. Whatever. My bad. If you don't specify a step, then the step is essentially just defaulted to 1, which is why we had 7, 8, 6, 7, 8, 9, 10. Because I specified the step to be 2, we have 2, 4, 6, 8, 10. I could specify this to be 3. This is 2, 5, 8. I'm going to also just split this. Just because there's a lot of code. That is 5s. There we go. And I could just run this section. It'll be a lot cleaner as well. Notice that if we go beyond our limit, like the next value here is 11, it doesn't actually get outputted. So this is like a limit where if you are in this boundary, you're included. If you are at the upper bound, you're also included. Because when I did this, running, 10 was included. But the moment that I changed the step value to make a value outside of the bound, that was not included. So keep that in mind. Likewise, I can also index backwards. I'm going to keep this like so. Or reverse. And that you need the step operator for. Because remember, the default is 1. So I can make a test case for this. All right, let's see what happens. So because I specified a step operator, I have every other number starting from 10. This one gives you an empty double row vector because we started cell block 10 and we're going to go the next one 1, but there's everything over here and nothing over here. Thus, we get an empty double row vector. So it's very important to specify your step size and which direction you're going. You could also do this as -1. You'll get the values 10 to 2. So keep that in mind. This is very important, especially for this exam coming up. Okay. Nobody's here. Okay then. I'm probably gonna end this at 12:30, since I don't really see anybody showing up, and that's a-okay of the exam. If you have any further questions, feel free to email me or so. And yeah, for masking it all, I would recommend going through any recitation resources or so if you're still stuck or anything like that. But yeah, this is where I'm gonna have to end it. Stop sharing. Perfect. All right. Thank you all so much for tuning in. If you have any other questions, just let me know. If you want me to make YouTube videos on this, I could potentially do that. Just let me know. All right. Bye, guys.